Hello, this is CIT 371 Linux System Administration. In this video, I'm going to provide you a basic Linux review. So the purpose of this lecture is to just go over some of the basics of Linux, the basic Linux knowledge and tasks that you studied in a previous course, most likely. So if you were an NKU student at the beginning, you most likely took CIT 171, which teaches you a lot of the basics of Linux. If you're a gateway student like I was once, you probably took the 200 level Linux class they offer, or at least did offer when I was a student. Um, but the thing of it is that you may not have had a Linux course at all. Well, that is why I provided an optional review lab. If you need a refresher on basic Linux knowledge and skills, please take the time to listen to this lecture, use the supplemental resources in this module, and then do the lab. This should get you back up to speed. To be fair, there isn't a ton of Linux knowledge you need to know to succeed in this course. Um, I'm going to expect you to be able to navigate the Linux file system. You're going to need to know how to create files, change their permissions, and edit their contents. Um, you're going to need to know how to use the Nano text editor, or at least some kind of text editor. I don't enforce Nano, but I do highly recommend it, especially if you're not a Linux super user or anything like that. Then finally, filtering command output. Those four on the bottom, those last four topics, are the core of what you're going to be accomplishing throughout the semester. I do include creating user groups more than anything just to teach you how to create command or how Linux commands work. The thing of it is that it's also an important task for a system administrator anyway, so it's covered here. So we're going to talk about user and group creation on Ubuntu. So what's kind of interesting about Ubuntu is that the preferred command to create users is a little different than other systems. So a lot of Linux systems use user add. You're probably familiar with that command. Um, Ubuntu, it's better to use add user. From my experience, user add misses some configurations that add user does. So you're better off not using user add. When I tried to use it, it created an account I could not authenticate into. There's probably a good reason for that, but I find that add user is better for Ubuntu. In addition to add user, there's also add group for adding users to groups. So yeah, that's basically the gist. How you're going to learn how to actually use the command in the lab, but just a little TLDR for that part. So something else about users, privilege escalation. So your server and client come with an account named student. So that's the account you're going to sign in every time you log into the VM. It was created to prevent you from having to constantly just sign in as root, which you really should do as a Linux user. When you work out in the real world, you really want to avoid just straight up signing into root unless you need to. The student user on its own lacks the permissions necessary to perform many of the administration tasks that we're going to accomplish in this class. So if you go to just sign as the student user and try to create a user, like run the add user command, it's going to fail because the student user lacks the necessary permissions on the system to do that. The thing of it is, there's something called privilege escalation. This allows an account like the student account in your systems to temporarily elevate permissions with the sudo command, and then be able to perform system administration tasks. So if you run sudo add user while signed in as student, you can then create the user. You're going to need to use sudo a lot in this class. I don't provide Ubuntu or the Ubuntu systems I've installed do not have a root password set, so you're not going to be able to sign that account. You're going to have to use sudo. Please note that very important. Don't run sudo. You generally do not want to run sudo when you're creating or editing files and directories in your student's home or student user's home folder. So if you do anything in here like create a file or edit a file, please don't sudo that. Because that's going to they change the permissions from the student to root. And then the student user can't use something in its account or directory. Let's go over directory navigation in Linux, something very important. So, in case you don't remember, directories are basically folders. They're the Linux equivalent to Windows folders. They basically are files that store other files. So a directory is like a folder that's storing a bunch of text files or something. So the Linux file system starts with the root directories. Hierarchical. It's a hierarchical system that starts with the very bottom, which is root. That is the root directory. Everything after that is located in this folder. So you can think of it like a folder that holds other folders that hold other folders and so on. This is the very first folder in Linux. So when you navigate directories in Linux, there's two ways to type out the path. There's absolute path and relative path. This is kind of important to know because some articles may provide relative path instead of absolute path, and if you're not in the right place, the relative path isn't going to work. So the absolute path is the path to a file directory starting from the root directory. So say we have a song.mp3 file in McBob1's folder or directory. It's in its download. So if we want to go there, you're going to run cd/home, and then you're going to go to the next folder /McBob1, then slash downloads /song.mp3. So basically, you're traveling from root to the home directory, to the McBob1 directory, to the downloads directory, and then finally your little song file. Now, relative path is a path to a file directory you want to get to, but you're starting from the directory you're already in. So, for example, download /song.mp3 achieves the same results as the absolute path you just ran here if you're located in home/McBob1. To explain this, say you just signed in as McBob1 into a computer, and you open the terminal, you are in this folder. You're in McBob1. You're in the home directory for McBob1. You want to get to song.mp3, but you don't want to type out this huge path. So all you need to do is cd, you just need to type the next folder that is in McBob1, which is downloads, and then you can get your song. So relative path is a shortcut. You don't have to use it, but it's a time-saving thing. Some articles do use it as well. It's something important to know, so just keep it in mind. So working with files in Linux. So when you create a file, you can use a text editor such as Nano to open it and then save it. But if you want to create a simple blank file, or empty if you will, just use the touch command. So you're going to need to use this command in part 3 of your lab, not a text editor, just to let you know. Files and directories in Linux have a set of 3 assigned permission values. These determine what users can interact with a file and how they can do it. So if you run ls.l, this command, if you run it, it'll show a listing of all the files and directories in the directory you're currently in, and it's going to show their permissions, each one's permissions. So here's an example of a permission code you may find. So I'm going to explain this to you. So the first symbol here, this is either going to be the letter D or a dash. If it's a dash, it's a file. If it's the letter D, it's a directory. So in this case, this is a file. We're talking this little guy here, this string, represents the permission settings of a file, because this first character here is a slash, or excuse me, a dash. So after this first character are 3 sets of 3 characters. So they're either a letter or a dash. So the first 3 here represent the permissions for the file's owner. The next three represent the permissions that the group has, the group owner of the file. So not only does the file have a individual user owner, but also a group that owns it as well. So any user that's in this group is affected by these permissions for the group permissions here. Now the last 3 are the permissions for all other users on a system. So if you have an admins group and you have an admin user, and then you have everyone else on the system, this string here could represent the permissions for that file owned by the admins group and admin user. So I'm going to explain to you what each of these letters means. So R represents the read permission. Basically lets you read the contents of a file, but by itself, read does not let you change the file. You can't write in it. You can't delete anything in it. You can't delete it. So if you put a W there, then you can edit it. You can change it and all that. X is special. So if you have a script, you're going to need the X permission because it's execute permissions. It basically lets you run a script. Basically, it makes a file an executable. It lets you run it like a script. So the dash here, whenever you see a dash, that means a permission is not given to a user or group. So for example, the Root user, or the owner of the file, can read, write, and execute this file. Um, the group owner can only read and execute, and then the outside world can only read. So permissions are very important for security. Some more things on working with files in Linux. There are 3 standard streams for controlling input and output. There's standard input, standard output, and standard error. So in other words, there's information that you're putting in to your computer, like through your keyboard, or for certain programs, you also have your voice, like my voice is being input. Output is what displays in your terminal. It's what you read. It's what's printed out to the terminal. And then there's standard error, which are error messages that come out from running a command. So you can edit the contents of files without opening them through standard output redirection. That's why I'm mentioning this here, because you can actually take the output of a command and then redirect it to be inputted, or to be redirected as input into a file. So there's 2 ways to do this. You can use a command. You can use this greater than sign, and then the file name. And then there's command 2 greater than signs, and then the file name. Having one symbol like this just redirects the output of a file and overwrites the contents. So if you want to not save what's already in a file and just add what a command is putting out, use 1. The important thing is that you got to be careful with this, because you can end up deleting some important information. That's why you generally want to use this. That not only redirects the output to a file, but it appends what is output at the end of the file. So in other words, it preserves what's already in the file, but also adds what you're adding to the file. It also adds your output to the file. So it's very important to be very careful with working with standard output redirection. Regular expressions. So, scary topic. It used to be heavily taught in this class. To be honest with you, it's more applicable to security or cybersecurity stuff and also computer science. It does have its place to a point in system administration, but to be honest with you, you can look up a lot of the strings you need. Like if you need a specific string, more likely than not, if you go to Stack Overflow or a similar website, somebody's already figured out the sequence you need. Or at the very least, you should be able to learn it enough that you can get what you need. So I don't cover regular expressions in this class. They are in the review lab a little bit at a very basic level. They are also covered in CIT 3D3 Scripting 1. So we don't really waste our time with them here because they're already covered in another class, and they're not really the most applicable topic in the world for the IT field, the server administrator or network administrator field. They have their place though, and that's why they're covered in the review. Um, the most frequent use of regular expressions for the Linux system administrator is when you're parsing log files or output. Excuse me. When you're doing file parsing, that's when you're going to usually use it. The way to do this is to run the cat command, which basically outputs the content of a file. Then you pipe it. So piping basically redirects what comes out from this command into another command. So grep basically is a filter command. So your regular expression basically dictates what you're filtering for. For example, if you cat a log and you just want to find the lines that have the term SDA, like the disk name, then you need to put grep and then in quotes SDA. That's your regex, regular expression, or regex. And that is how you filter output. I do have a tutorial here if you want to read it. If you want to pull up the PowerPoint slides from Canvas, use this article. You can learn a little more about basic regex usage. So to end this lecture, we're going to have a little lab overview. There are 5 sections in the Basic Linux Review Lab. They each focus on the topics that I've covered in this lecture. You can use this lecture as a guide or to give you some tips on how to complete what's in the lab. I'm going to help you put into practice what you learned in this lecture, so you'll have the foundational Linux knowledge and skills needed for the rest of the course. I've actually toned down the difficulty of this lab compared to the last time I presented it, because a lot of people haven't touched Linux in a long time, struggle with it, and that's completely understandable, especially if you haven't touched Linux in a long time. This lab is pretty guided compared to most of mine. I do have you look up a few things on your own, but a lot of it is given to you already to help you learn and get ready for this class. But thank you very much for listening to this lecture. I really appreciate your time. I hope you make good use out of what I've provided for you to help you prepare for this course, to help you refresh your Linux knowledge and skills. If you do still need help or need help with the review lab, please do feel free to reach out to me. I am more than happy to help you. I thank you for your time, and I hope you have a wonderful day.